Hello, we're going to look at a couple of different things today. First thing we're going to look at is the distance from a point to a line. We're going to learn some new theorems about perpendicular lines, and then we're going to finally look at some proofs involving perpendicular lines. So the distance from a point to a line, as you can see in the diagram here, if I have point A and line K, the distance from point A to line K is that perpendicular segment that connects point A to line K. Remember that perpendicular means that line segment AB and line K are meeting at a 90-degree or right angle. So we have to go back to our old friend, the distance formula for this, to find that distance from A to B, which we usually write as just AB without the segment symbol over top, this right here. AB is going to be, we're going to find that using the distance formula, which we've seen has just been a while. So in this example that we have in the picture here, it'd be impossible to find that because we don't have coordinates for A or B. But in the examples we're going to see here shortly, you will have those coordinates so you can use the distance formula. Let's take a look. So in this first example problem, they want us to find the distance from point A to the line BD. So there you see lots of segments in this diagram, but the one we care about is this perpendicular one that connects A to BD, which is going to be segment AC. So segment AC is what we are looking for. The length of segment AC, remember we don't write the segment symbol over top, it's just AC. And the way we find that distance is with using the distance formula that I have up there. It is subtracting your x coordinates, squaring them, and then adding your y coordinates subtracted and squared, like so. I'm going to label x1 and y1 and x2 and y2 because I think that makes life easier. Just pick one of the points to be the first point. I'll pick A. So it means x1 is 1. Y1 is, or x1 is -3, y1 is 3. So I'm going to say that letter C is my second point, x2, y2 right there. So let's put things into our distance formula. So x2 is 1 minus x1 is -3. And then we need parentheses squared. That takes care of our x's. Now we add, doing the same idea with our y's. y2 is -1 minus y1 is 3. And then again, parentheses squared. You could work this out by hand. You're probably, in most cases, going to get a decimal answer. And you can also just use Desmos. That's what I'm going to do. Everything after the equal sign goes in the Desmos. So square root, there's a square root button on your calculator, and Desmos there. 1 minus -3, close your parentheses, squared, plus parentheses, -1 minus 3, close your parentheses, squared. In a lot of cases, you'll get a long decimal, and that's okay. We're going to round that to 2 decimal places. So we are going to say that the distance from point A to BD is going to be this number rounded to 2 decimal places, which is going to be 5.66 units when you round. Let's try one more like that. So now I have the distance from point E to FH. The segment we care about is the perpendicular one, which is this one right here that's got the right angle marked. We're going to use the distance formula just like we did before. x1 is -4, y1 is -3, x2 is 1, y2 is 2. So then let's plug things in the distance formula just like we did before. So what we're looking for is the length of segment EG, that's the perpendicular one. I'm going to use that same formula from before, but since we haven't used it a lot lately, I'm going to write it out again just so we have it under our noses. And what I'm going to do this time is kind of pre-fill out what I need. I know I'm subtracting and then squaring, plus subtracting and then squaring one more time. Let's put numbers where they go. x2 is 1 minus x1 is -4. So it's going to look like 1 minus -4 here. y2 is 2 minus y1 is -3. And that's a -3. I know that might be a little hard to read there. So let's put things where they go in the distance formula. So square root 1 minus -4 parentheses squared plus 2 minus -3 parentheses squared. When we do all of that, we get a crazy decimal. Let's round that crazy decimal to 2 places. That would be 7.07 when we round that. So the distance from point E to FH is about 7.07 units. In the next video, we're going to look at some theorems and some proofs.